Alright, I messed around a bunch with my camera setup and stuff. I think I got a easier to deal with camera angle. It used to be a mess, just like where I was with a tripod, but anyway. I realize now that the window with me, my face in it is a little, it's kind of in a bad place. Since you can't see the JavaScript I'm typing, but I'm just gonna deal for now. Okay. And right now what I should probably do is get the shaders working. Hey, Blake496, what's going on? So if you remember from last time, I was slowly getting to a point where I could get Python running or Manim running in Pyodide. And I'm now able to import Manim. I hope. Yeah, I can import Manim. And it's the real Manim. Complete with all the constants and everything. And what I'm eventually gonna have to do is get the code running from here to interact with the window here. And before that, I think I'm gonna just try to get any shaders from Manim to render in Three.js. To do that, I'm gonna have to use their raw shader material. And hopefully this will allow me to, this will give me full flexibility over the data that gets passed to the shader. And basically just use this as a direct API to WebGL without using any other Three.js features. So if I use a fairly simple shader, this shouldn't be that complicated. I guess the vectorized object fill ones, vectorized object fill and vectorized object stroke are probably the ones that I want to do this with the most. The stroke ones are going to be kind of insane. Here's what I'll do first thing. Let me get the OpenGL example scenes. Go like here. I'm gonna do OpenGL tech. And just write a sum equation. So, that's 5x squared plus 3x plus 7. Something like this. And that didn't work. Maybe math here. Okay, that's great. And this is a single object. I'm actually gonna start even simpler. I'm just gonna put like X. Then later on I can deal with combining a bunch of them, so that'll be fine. Now given this, I think I want 0 at 0 data at points. And it didn't print all of them. I forgot how to make NumPy print all of an array. Set print options. Although I also know there's a way to write NumPy arrays directly to a file. I won't deal with that right now. Actually, so for this there's stroke and there's fill. Let me go ahead and set this. For the fill ones, I'll have to do triangulation. For the stroke ones, I don't have to do that. So just because triangulation is going to add some complexity, I'll do the strokes first. Okay, and I'll just output this to a file. x.txt or something. Great. Maybe I should first try something even simpler. How can I even read the shaders from here? Talking on that get element by ID vertex shader. So in this they wrote it into the source code. Oh, this isn't the example. Where is it? I thought they had an example for this. This one. So here they just wrote out the vertex shader and the fragment shader in the source code, which I probably won't want to do. So let me do this instead. I'm just gonna have like a shaders file. Source, so probably under like source shaders or something like that. Then I can just copy the paths directly from Manim, I guess. Vector isometric fill, vector isometric stroke. Actually, I can literally, I should be able to just copy these exactly, I think. So I'll try doing that. CVR. This, the shader folder. Source. Make the shaders directory. Copy them. /star. Yeah. So now, source shaders contains all the Manim shaders. Great. That's probably more than I need. But that's fine. Now I don't want to have to fetch a file or anything like that, so I'm going to put this in a constants file or something like that. Source shaders. Make something like shader constants. Or like shader source. .js. And I'm not even sure of the naming convention for this. Everything in components is like camel case. Main.js is lowercase. Looking to add some, I think this is right. I don't have like, I just get the basic, the most basic shader first. And for that, shaders, I think there's actually example or test material or something like that. It was default. Before default, I'll use test though. Okay, so test.vert. And test.frag. Let's call this test.vert and then copy in all of this data. Okay. Test frag. And copy in this. Okay, so that's great. I might have to add some directives for precision for WebGL, but generally this is pretty much what I want. And I'm gonna put together this geometry, this buffer geometry, and push in the attributes, which would be basically nothing. Not the buffer values from 0 to 1. Interesting. Okay. So this, okay, so when this mounts, it's creating a geometry and material right here with the basic mesh basic material, box geometry. New setup, yeah. This is a little bit less annoying for me to deal with in terms of like wires. Before I had like a tripod set up and stuff, and it was just really annoying. Okay, so we have this. Let me create that buffer geometry. Like so. Maybe I should call this something else. I'll just make this geo and mat. Now I can call this geometry. So I have a buffer geometry. Wait, what? Oh, you create attributes from regular JavaScript arrays. How is this const colors and const positions and it just pushes to it? Interesting. What I'm gonna need is invert and in color. Invert equals an array. This color also an array. Okay, I'll make this, try to make this really simple. Actually, I don't think I want this const. Let's do this, then I can say invert equals. So it's just pushing 3 things, and then you specify the size of the data when you convert it to an attribute. So let me put one at, I guess I'll just do the half screen triangle thing. So -1, -1, 0. -1, 1, 0. And then 1, 1, 0. Then the color. Looks like this uses RGBA by default. I guess, which is nice. Because it means I don't have to do it. And I'll just make this red. RGB, then A. I might as well just do this like that. Okay, then I can make the vertex and color attributes. New flow 32 buffer attribute, do this. And I'll use invert. And for the colors, why are these integers? Oh, these use floats and these use ints. And it's up to 255. Okay, so I guess I want... Well, that's different from Manim, I think. Oh, and I want this to be 1. Wait, even alpha goes up to 255. Interesting. Okay, so I have invert in color. Okay, so I can do that, and it's 4. And it's a uint 8. Like this. Counts prevents a reassignment, does not prevent mutation. Okay. That's fair. I guess that'd probably come in... I think I actually remember reading about this. That it can be sometimes bothersome in JavaScript. Because we do like const object. Then you can still just like do whatever you want with this object. Yeah. Okay, color attribute dot normalize. Oh, so it buffer values from 0 to 1. So I guess you can do it from 0 to 1. I guess I'll do this line for now and just normalize them. Okay, so then this would be the material. I have a raw shader material time. We don't need the vertex shader. Gonna import shader source. It's kind of a weird way to do this. Stars. I'll do it like this, I guess. Now, hopefully, I can do shader source dot test underscore vert, and then shader source dot test underscore frag. Double side is fine. Transparent. Does this like... I'm not sure what transparent does. Probably makes the alpha channel work. Determines whether this material is transparent. This has an effect on rendering as transparent objects. Needs special treatment and offer rendered after non-transparent objects. The extent of the material is transparent and controlled by setting its opacity property. Okay, it probably makes the alpha channel actually do something. It's probably what it does. There you go. Now I have this material. Where's the geometry? Okay, so the geometry holds the attributes. Geometry.set attribute, position, and color. So I can just bring this here. I honestly could have done this inline. Oh wait, and this has to be invert. This has to be in color. I will actually do this inline. Okay, both of those. So those are the vertices, 3 vertices, 3 colors. Wait. I said attribute with the attribute object, so this is not correct. This needs to happen down here. Vertex attribute, color attribute, like this. So if I want to do this in line, I'd have to do like this. And this. Which admittedly looks kind of messy. There, that's as unmessy as I can get it. Okay, normalize that. Hey, Gerald Golden, what's going on? Okay. Change this again. That. There's the material. Then I can make a mesh like this. Do that mesh geometry and material. Now there's nothing to do but add it. So yeah, then scene.add that mesh. All right, and I broke everything. Oh yeah, shader source. Source shader source. Does this need to be like, but this is in the components. It needs to be like that. Filter bar source for input analysis because the content contains invalid JS syntax. I didn't know this. Oh, this is Python. I think I had to do this like this. Hopefully. Test word is not defined. Uncount reference. Oh, I have to do let or something. Or it should be const. And I think I actually have to export these. The fact that I don't know JavaScript that well is really showing. Okay. What do we got? Well, it was starting to be compiled. Invalid version directive. In storage qualifier supported in GLSL 3.0.0 and above only. So I guess that version isn't right. And that's the first thing it didn't like, is the version directive. 330 seems pretty normal. We look at... I think I have the 3 shaders somewhere. And the Manim could actually... I don't think I pushed that. Yeah, I didn't push that up, so I don't have it anymore. Darn. What I can do is go to the tutorial or something. Then when I read the shader from 3JS, just print it. So I can see the header. So I look at Git 3 mesh. Material, blah, 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 blah. So Git material is gonna do this. Okay, so here it's gonna, here it gets access to the vertex shader and fragment shader. So I'm just gonna print these. Material response. So then, if I run this, okay, now I can see how this top of the shader looks. Hopefully. Version 300 ES. Wait, did this get... Is this 2 shaders? Or why is this happening twice? Oh, it's doing this for each object. Which is pretty wasteful. That should be cached or something, but whatever. But fine. Okay, so let me try that, I guess. No, it still doesn't. Version directive must occur on the first line of the shader. Okay. Just really make it uglier. Okay. Invalid or unexpected token. I wonder if it was from those semicolons. Shouldn't need the backslash, okay. I will take your word for it. Okay, what's the complaint this time? Client/version number not supported. Oh wait, I don't think I need 330. 300 is probably fine. Oh, still. I'm gonna say invalid version directive. Isn't this the same one from... Yeah, here. Version 300 ES. Use program not valid. I guess I'll try it one more time. No, same thing. No precision specified for float version 300. That's true. Oh, it's for the fragment shader. Does that mean the vertex shader was okay? Oh. So then for precision, I'll just copy their precision. I'm actually not totally sure what the precision strings even do. They don't have a hash at the beginning. Okay. Well, there weren't any errors. But my shader isn't here. Scene.add mesh. Yeah, I added it. That's annoying. Maybe what I'll have to do is start from their example. Basically this one. Actually, wait. Yeah, basically start from this example. And then slowly change that one into the shader I want. I get the geometry, get the material, add it. What could be left? Invert in color. It's the vertex attribute, it's a color attribute. I wonder if this needs to actually be 1.0. Because it has to be parsed as floats. And it looks like the material is working okay. Try that again. Yeah, I still don't see it. That's annoying. So one more thing. I'm going to take out the cube. Cube's not defined. Right. Yep, guess that's not appearing. Well, that's annoying. Oh, this is a vec2. Maybe that would do something. Well, I guess that would do something. Okay, try it again. Same thing. Darn. Oh, I have to change this to a 2. Luckily, since I make so many mistakes, I get a lot of second chances. Okay, but it still doesn't work. Darn. Vec2 in color. I wonder if this needs to be a float 32. Okay. Now I'm trying everything. Because that's just how much I don't want to use their example. Then I don't have to normalize that. So now it's 4 floats. This is 2 floats. Set invert, then in color. Is this supposed to be frag color? I think it is. Okay, do that again. Looks like the same thing. I'm gonna check their shaders to see if it's frag color that they output. Let's search this. Well, I can't find frag color. Oh, because this is the vertex shader. Got the fragment shader. It's GL underscore uppercase frag color. Okay. V color. So it should be like this. And is it a Vec 4? Geo varying Vec 4. Oh, it's not even listed here. It's just global, I guess. But it's a Vec 4. GL underscore observed built-in name. So I guess that means I can't have this here. Dude, they said GL position? There are so many little things to get right. GL position is right. Okay. GL frag color, undeclared identifier. So I guess you have to declare this somewhere. It isn't declared here. If I look here. Yeah, this isn't a varying or anything. But then here it says undeclared identifier assign L value required, can't modify a const, and dimension mismatch. And cannot convert from in high P4 component of float to high P of float. I guess these are both medium P. I guess it has to be a high. It's still only the fragment shader, I guess. It really wants me to do something with GL frag color though, and I have no idea what. Because here, this is the only mention of it. But then main. Darn. I think I'm gonna have to use their example. I'm gonna search this error one just one time. GL frag color undeclared identifier. See, there's a way that you have to, when switching to GLSL 300, because it has to be, wait, modern versions of GLSL do not do fragment shader outputs simply by declaring those out values. And geofrag color is no longer supported. Okay. Okay, now it compiled, but it's not appearing again. Okay, I got to copy their example. Unfortunately. Yeah, I don't see what I did wrong there. Object rotation Y. Yeah, okay, guess I'm copying this. From here? Wait, what is container? Oh, that's where it's putting the renderer. Okay, so I have to take that out. I'll copy this much. Okay, and all of this... Yes, I'll just comment. Okay. So now container stats, camera scene render. I won't need all of these. Where does it attach the renderer? Here. So WebGL render, device pixel ratio, sure. Then append the DOM. I guess that's fine. Although this stats import won't work. I don't need it though. Okay, see if that works. And I doubt it will. Text content of null, that's true. So here, I might just put these shaders in directly. It's not that, that's kind of a lot of code. I'll call this docs vertex. Put this here. And then docs fragment. Actually, didn't need to yank that. The fragment shader will be this. Okay. Oh, it should have been revert and frag, I guess. Okay, do that. Then for this. Docs, vert. Docs frag. Let's see if I can make this work. Docs frag is not defined in the module. Oh. Both of those const. Okay, hopefully that'll do it for that. Append child of null. That's true, there's no container here. Or even was container. I'll just append it to like the body or something. Oh, it's by ID. Get body element, sure. So just document.body. Hope that works. Okay, so I managed to render a shader. It just happens to be exactly the one from their example. Wait, but there's something else up with this. The positions... Okay, so that's the... Oh, this is using a model view and projection matrix. Oh, but they're optional. So they're not being passed, so I guess this is just the identity? Oh, you know what it probably was? I might not... No, I was putting them out as homogeneous coordinates. Yeah, I don't know. Guess I'll just have to incrementally change this one into the one from Manim. Starting with the renderer. Let me put that where it's supposed to be. Canvas document get an element by ID whatever. Okay. Well, it didn't like that. Can't read render of undefined line 184. It must be using this renderer. Okay, I'll try that again. Camera is not defined. Wait, did I delete the camera? Okay, I'm gonna go back to the thing that worked. Alright, so there's shader's rendering. Take out this renderer. This will be const renderer. I'll do it like this. Same thing. I guess the renderer has to be defined outside that function like that. Okay, so can I just do this? Take out this. Okay. So I managed to push it on the top at least. Let me set it to the height I actually wanted it. Because now it isn't square anymore. Is this because of the set pixel ratio? It isn't. Rendered at set size. Do I want to do this? Darn. I do not know 3JS. Okay, so here, it's rendering the way I want. Can I zoom out of this, please? Oh, now it's always the maximum size. Window.inner with window.inner height. So I have to resize the viewport without resizing the, without stretching the space. Wait, if I put false here, I guess that did it? I put render with renderer height. But that doesn't work. Actually, I think that's expected because I'm not using a model, I'm not using a projection matrix specifically. What isn't that expected? Math.random minus a half. So math.random is from 0 to 1. Oh, so these are landing from negative a half to positive a half in normalized device coordinates. Okay, so I think this does make sense so far. It's in line with my intuition, at least. Great. I'm gonna take this off. Take out this resize logic. Take out this stats. Then I have to incrementally move this into the test shader that I've been using. And the container isn't used, thank goodness. Just camera scene and render, so this is function init. Then there's function animate, then there's function render. Oh, and at the start it's calling init and then animate. Okay. This is all within the on-mounted callback. So what I'm going to do... Wait... Animate... Does request animation frame of animate, then it renders? So then it'll call render. Renderer.render. Oh, and then it's calling itself. This is a pretty confusing way to do this. Why is the request animation frame here? So request animation frame render. And then you just call render once. Just call render here. That goes into this. That does all of this. Then request animation frame back into render. I guess it's a little easier to follow if I put that here. And all of this init logic can come out of function init. There. And, oh wait, on window resize. Don't need that. Okay, cool. Great. Okay, so now I can render these. Last object. Okay, then it's rotating that. Now I should be able to not declare these variables in such a weird way. Now, like this. Okay, so that's the same thing. I increase this. Ooh, that doesn't make sense to me. Wait, is this a shader material or raw shader material? This is raw shader material. I didn't know this was affected by the camera. Weird. I thought you'd have to pass the uniforms for that in manually. Since it's raw shader material, I guess not. It says definitions of built-in uniforms and attributes are not automatically appended to the GLSL shader code. Oh, but even in this code, it does have a model view matrix and a projection matrix. So maybe if I remove these lines. Oh, and then I can't use them if I do that. Okay, that's actually what I'd expect. Yeah. Interesting. And that's actually... I mean, it looks uglier, but I'm going to keep that because now I can see all the attributes that are being used in the shader. Number of triangles with 3 vertices per triangle. Sure. I'm gonna change this to 1. Alright, so now I have 1 triangle. So now, if I made this... Yeah, take out this. And then 3 times I have to do R, G, B, A. Like so. Alright, now I got that red. Wait, why is this randomized? Oh, the positions are random. Okay, so I'm going to take out this normalization line. Try to make this a 1.0. And I actually suspect this will break something. So try to make this a float 32. And nope, that still works. Which is good. Then... now I can try doing this. So -1, -1, 0, then -1, +1, 0, then +1, +1, 0. Great. And it's the fragment shader that's doing that with the color. So I could... Great, so now I have my half-screen triangle. That, I can take out these uniforms. And I broke something. What did I break? Okay. You have to pass in time? Try to remove that. And remove that. Canvas.view 131. Oh, here. Material uniforms time.value. Okay. Great. So I don't need that now. And bring this geometry down here. I'll bring this back down. Cool. Double side, transparent, true. Add that mesh, renderer. Set to render width, render height. Rotation. I guess the rotation would only matter if I used their camera, which I'm not right now. So I can just do this. Background. Sure. So now increasing the Z position shouldn't do anything. I shouldn't need this perspective camera. Okay. Oh, did I break something? Oh, you have to pass a camera when you render. Pass null or something? Guess you have to pass a camera even if you don't use it? Weird. Okay, now I'm gonna try to change some of this so that I can use the Manim shader. For one thing, it doesn't use in, it uses attribute. So much of this is really similar. Okay, so here's the test vert. Here's the docs vert. It doesn't even have the version string. Okay. So I'll just leave it without the version string. I'll keep both these medium Ps. I'm gonna try to make this into effect 2. That'll be the first thing. Like so. And positions. So that's 2. So that's effect 2. Now there are only 6 of these. And then That'll be position 1.0. 0, 1.0. Now the variant will have to be a vec2. This has to be vec2. Actually, I don't even need this varying. V position. It isn't used in the fragment shader. Great. Okay, now I'm going to change this from position to invert. Don't need this varying. And I broke something. Does this have to be called position? I think there's a chance it does. The position attribute is likely to have NaN values. Computed radius is NaN. Don't know what that means. Bring us back to 3 dimensions. I guess you have to pass 3-dimensional positions. Which I guess is fine. Kind of annoying though. But just by making this 2-dimensional, making this a vec2, I think that on its own is an error. Yeah, buffer geometry compute bounding sphere. Bounding sphere. That's kind of annoying. Because sometimes you're just not using 3-dimensional points. Can reach the radius based on this vector 3. Generated geometry which actually represents the geometry of your geologic surface. Okay. I guess you just always have to use 3-dimensional positions. Oh well. I guess that isn't a huge deal. You can always still represent 2-dimensional stuff that way. Okay, let me see if I can change it to invert at least. Take out this, take out this. Okay. And you can't. That's really annoying. I guess you have to use the name position. No wonder this didn't work. There are a lot of things that this imposes. None of them should matter for Manim so far. I mean, this must be general enough that this doesn't really end up mattering. But that is kind of annoying. Oh man, what'd I break this time? Oh, it's still called invert. Okay. Okay, then I can just call this V color if I want to. V color equals color. V color for this. V color for this. Great. I guess it just has to be called position. Like, non-negotiable. If I call it like in position. Well, let me see if it does that with color. If I call this in color. Surely this will still work. And this still does work. It's just position, which happens to have special meaning to Three.js. I'm still gonna try one more time. Make this in position, make this in position. This in position doesn't work. Okay. Guess we're using position. Great, but this is still good. Wait. Yeah, that'll never become a problem, I don't think. Since I guess it is a little inconvenient that you have to pass in a position attribute, I guess. Since sometimes you may like compute some weird function of this. Yeah, this may not even necessarily reflect any sort of radius, because this could be transformed into something totally different by the time you set GL position. But I guess that's what Three.js likes. But okay. Maybe I should try to put it through the Manim's projection matrix and model matrix and stuff. Guess it couldn't hurt. What I'm basically doing is I want to set up a few scenes, like scenes that basically just show this, and one that'll show this projected, and one that'll have model view and projection, etc. And that's going to be a little bit harder, at least harder than it is in Manim, because I don't have any of the infrastructure set up to save multiple scenes like that. Unmounted, I basically do all of this stuff. Scene, camera. Instead of the renderer here. scene camera render, geometry and material, add the mesh, and then I just render this here. So I can factor all of this out into a function like half screen rectangle, half screen triangle. Yeah, just so I can keep that handy for the next time I need it. Source, I'll put source like shader scenes or something like that. And here I'll just try just copying all of this. Wait, what in the world? Did I copy too much? This needs to be basically a function. Scene. This, import 3JS here. And then maybe I can say just on mounted. I can import shader scenes. Shader scenes dot scene. Although this doesn't have access to the shader source stuff, so I'll have to change some of this. Can't destructure property default of undefined. What? Shader scenes JS line 3. We have to do this. Render width is not defined, that's true. Where's render width even used here? Oh, right there. I'll just pass those in. Or like this, render width, render height. And then we got to import the shader source stuff. Like so. Only I think it'll just be like this. Okay. So I can remove all of this. And I don't need shader source or 3. And I can call this have screen triangle here and here. I can do shader scenes dot have screen triangle. Arpit's Piano Hits. Thanks so much. A nice name, by the way. Okay. So I managed to get this super basic, came from Discord. Nice. Hope you're enjoying using Manim. As much as I'm enjoying debugging JavaScript. which is some. This is actually... This looks like not that much. But this is the first time, I think ever, that, oh my gosh. Tutorial.py not found. What? GitHub Manim. How does it say tutorial.py not found? OpenGL tutorial. Oh. Okay. So what I was saying is this is effectively a Manim scene, which is finally running, like, completely in the browser. It doesn't have some of this interactivity, of course. But, yeah, that's moving in the right direction. Okay. So after that, I'm gonna want one that uses Manim's projection matrix. I think that's what I want to do next. How much of this do I not need or not need to redo? Like getting the renderer? The scene camera render stuff. I guess I can just copy that. That's not a big deal. Yeah, whatever. Now I'm gonna try one with a model matrix, I guess. Oh wait, both of these. So start from this. I just won't do this. That, rerun it. Same thing. Okay. First things first, I want to project the coordinates of this triangle. Which means I need a projection matrix. So I go to utils OpenGL. So I want essentially this. So we go into basically any Manim scene. I'll just print the projection matrix. Yeah, that's it. I'll just print it. And not formatted. Okay, then if I run cascade triangle. Great. So positions, colors, is geometry. Now here is the matrix from Python. And I think the way to pass matrices in JavaScript is like column major order. This will actually be, this might get annoying, you know, eventually. Because I don't have NumPy to make NumPy to do like easy manipulations of matrices. Guess I'll deal with that later. Right now I can just do this. Wait, I'm gonna look this up. You recommended to update custom uniform values depending on object and camera and object 3D on before render. Because material can be shared between meshes. Okay. I mean, I guess it. Hold on. Somewhere they go over their default uniforms. Does built-in uniforms and attributes are not automatically prepended to the GLSL shader code? Is it gonna say what those are? Okay, well here it goes over. So you can pass matrix 4s as float 32 arrays. Okay. It isn't saying how to do it with matrices though. As far as a JS library for it, yeah, that's probably true. Just passing by to say hi, I haven't been to your Twitch in a long time. Your desk looks great. Thanks. Although I guess you can't see my desk right now. Which, honestly, I was sort of reluctant to switch to this view because... Oh, here it is. Uniform Mat 4. I don't know. I mean, these must be passed in. Oh, it actually... Now I see what it was saying before. When it was saying you can pass in matrix 4s as 3.matrix 4s. So I can just do that. Okay, but anyway. It was more streamer-esque. I think I know what you mean. As in... There's not, like, a lot of background decorations and stuff. I might try to go back to it. It was just so complicated. There's like a tripod set up behind me and stuff. Yeah, I might see if I can make this scene more, or this view more streamer-esque. And if not, I might just go back to it so I can be more streamer-esque. Yeah. We'll have to see. The, like, tripod and stuff is just so annoying. Okay. So we go to how this thing passed uniforms. Like this. No gaming chair. Well, gaming chairs are actually not that great. They're pretty much just height. What you'd really want is an ergonomic chair. And that's probably what I'll end up getting eventually. I probably should have gotten it already, because I spend a lot of time sitting here. I don't see why this is an object. New uniform. Like value? GLSL variables that are passed to shader programs. Each uniform must have a value property. The type of the value must correspond to the type of the uniform variable in GLSL code as specified by the primitive GLSL types in the table below. Okay. Uniform structures and array. Wait, uniform structures and arrays are also supported. What does that mean? Maybe it means like a structure of uniforms or something like that. GLSL arrays of primitive type must either be specified as an array of the corresponding 3 objects, or a flat array containing the data of all the objects. The words GLSL primitives in arrays must not be represented by arrays. I don't understand any of this. This rule does not apply transitively. An array of 2 arrays, each which a length of 5 vectors must be an array of arrays of either 5 vector 2 objects or 10 numbers. Okay, so that makes sense. Value. Okay, so this is a struct. Data. Okay. I think this makes sense. So I guess you can pass a uniform object. An object containing the value to set up the uniform. Okay, and then that allows you to pass these. Okay. So I think that makes sense. Then what I want to do for like model matrix, I want to do new 3.uniform new 3. Okay, then for a matrix 4, I can do a 3.matrix 4, which I can't open a new tab. Which I guess you can't just initialize. So to do let model matrix equals new 3 matrix 4. Then this dot set. And when I call set, then I have to set all of these like this. Okay, and these values are going to be straight from Python. One dot 6875 zeros 0 3 0 0 0 0 that. Then 0 0 -1 0. Okay, then now I should be able to do this new 3.uniform. Okay, so that should just not crash, I guess. And it isn't crashing. But I'm not using this uniform. Wait, this isn't a model matrix. It's a projection matrix. This is a projection matrix. That should be projection matrix. Okay, and that. We go to the default shader. Just calling it U projection matrix. So just so I'm consistent with that, I'll put a U here. Great. Where's this reading the shader? Okay, docs vert and docs frag. Now, this should actually be... This should be test vert and test frag. And get rid of those. Because this is the way it has to work in... the way it has to work in 3JS. Great. So my goal right now is just move this from test vert and test frag into default vert and default frag. And the only difference between the test shaders and the default shaders is that the default ones are projected into Manim space. So I want this. Now here, the U projection matrix. So I hope I remember GLSL uniform matrix for so I just tried this and it disappeared. Great. Darn. Look at this. Yeah, just multiplying it. Uniform matrix for that. I don't think it would matter that these are floats. I don't think. An array containing... Oh! Right, no, that's fine, that's fine. This is specified row-wise, and then it's automatically converted into being column-wise. They are giving all these methods to, like, use their stuff instead of trying to do this by hand. Raw shader material and giving it this projection matrix and passing it to the default vert. The default vert has this U projection matrix. Okay, let me see if I can do this with the identity. I can see if this is a problem with the matrix or not. And with the identity matrix, this works. So why would that happen? It should be fine to use the projection matrix without a model or a view matrix. Actually, no, it should be. X, Y, Z. Okay, I guess I'll have to start with an identity matrix. Okay, so let me do this. I might know the problem. Okay, so this will work. Is it this -1? This is gonna scale the X dimension. This is gonna scale the Y dimension. This is gonna flip the Z dimension. This is gonna translate in the Z dimension. I actually don't know what this -1 does. I actually don't think it's fair. It's valid to use the projection matrix without a model and view matrix. I think I have to use a special projection matrix for that. And I think I said as much in this projection visualization. Here I'm using an orthographic projection matrix. Maybe I should just start with that. And then here I'm also using an orthographic projection matrix. It's only for the view visualization that I switched to a perspective one. Well, that's okay. I guess I haven't tested what I'm doing in JavaScript in Python. That's what that means. In fact, here's the projection visualization, and I'm using this, the orthographic projection. Wait. Yeah, I'm using the orthographic projection matrix. So this is what, wait. Alright, this is what this looks like if I slide it. If I were to switch this to the perspective, does this even work in Python? And it doesn't. Which means I could never hope for that to work in JavaScript. That's what I really need to do. Let's print this. Copy these values. Not those. This is what I'll try passing. This 0, 0, 0, this 0.25, 0, 0, minus 0.1, minus 1.1. And it still doesn't work. Perfect. But at least somebody followed. Entice. Thanks a bunch. Because I am feeling the pain of OpenGL right now. Okay, let me at least format this right. The resources to understand how model matrices are derived. Model matrices in particular are pretty straightforward. You don't have to know that much to derive them. You'd find basically everything if you Wikipedia affine transformations. For certain slide and parallel, but not necessarily just angles. I think this. Well, wait. Okay, this is too general. Oh, well, no. They have them here. It's basically just one-to-one with, well, it's exactly affine transformations. Although this is like fairly general. This looks a lot more digestible if you search transformation matrix. And it's just these, basically. That's what model matrices are. Okay, but this projection is not working. Transformed mesh.attributes at position. I guess in this case, I'm multiplying by the matrix outside of the shader in Python. Let me see if I put a 1 here. I guess this should work. And it does. But then why didn't this work? Why isn't this what I did in Python? Oh, in Python, my positions, -1, -1, 0, 1, -1, 0, 1. No, that's the same. I think. Yeah, that's the same. So why is it this is okay with getting those negative values? This is basically flipping the z coordinate, and this is translating in the z direction by -1.1. -0.1. This should scale it. This should make it disappear, I think. But it doesn't, because I don't understand model matrices that well. Oh no, that makes sense, because its z-coordinate is 0. So when I flip the z-coordinate, it doesn't do anything. Okay. Then when I translate the z-coordinate by -1.1, so of course that would bring it off the screen. But if I did that by -1.0, then it'd still be on the screen. So how did this work in Python is my question. These are the, wait. Yeah, these are the transformed coordinates. X, Y, Z. Then the W coordinate is 1. Okay. I have to do this multiplication on my own to see what's going on here. which I don't really know how to do in 3JS. From away, extract rotation, blah, 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 blah. Multiply matrices, multiplies the column of this matrix by vector v. That's a weird... Oh, this is only a vector 3. I don't think that's what I want. How do you multiply by a vector? It's a transformation. This allows a vector 3 to undergo transformations. So the translation, rotation, shear scale, reflection, orthogonal, blah blah blah, by being multiplied by the matrix. Is there like a dot apply? Make perspective and make orthographic. It must be something, it must be a vector method in that case. Right? 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 Apply matrix 4. Multiplies this vector with an implicit 1 in the 4th dimension and m. And divides by perspective. Okay. So, I'm going to take this vector 3. Actually, no. At points or positions? No, points. This can be 3 dot matrix 3. I don't know if I can multiply a matrix 4 by a matrix 3, but I basically want to apply that matrix to each of the positions, each of the points or whatever. Okay, that's gonna be too annoying. Vector 3. I'll just have -1, -1, 0. -1, 1, 0, 1, 1, 0. Then transformed. And this is going to be 0.1 dot apply matrix. Apply matrix 4. Projection matrix. I'll do that with this one and that one. Then I'm gonna print these. And see what these are. And here, the z coordinate is -1.1. But in Python, right over here, the z coordinate is 0. Why? Why? This is really weird. Transformed. Okay, so I'm gonna print untransformed mesh dot attributes of position. Then I'm gonna print the orthographic matrix. Then I'm gonna print the transformed points. Okay. Okay, so each of these... Oh, wait. Position... I'm right multiplying. Which, that's fine though. That's just because they're row vectors. And I get this. It's almost the same as what I get in JavaScript, except for the z coordinate. Which in Python it's 0 and in JavaScript it's negative 1.1. Maybe I just have to do this matrix multiplication. I mean, I can do a matrix multiplication, right? But I'm gonna do it here. Okay, so the matrix is this. And the vector is -1, -1, 0, 1. So m dot x is going to be -1 times -1 times this plus -1 times this. Whoops. Plus 0 times this plus 1 times that. And that's going to equal so negative that, and those are all zeros. Basically, I only care about the z coordinate, so this. So that's 0, that's 0, that's 0. And this is 1.1. So whatever the answer is, it's going to have negative 1.1 in the z coordinate. Which means JavaScript is right. Unless... No, yeah, it's just right. Unless the perspective divide does something weird. I guess I'll just compute the rest of this. So I have negative that. That's the x. That's a 0. Negative this. This is the y. Z. That's 0, that's 0, that's 0. Negative 1.1. Then the w. 0, 0, 0, and this is 1. Okay, so this is m times x. So now the question is, why is it that when I do this in Python, I don't get that negative 1.1? It is left multiplying, which is sort of weird. I'm just gonna break here. Which means at the end of this, I have to do a wait. Okay. So I can print attributes at position. So those are the points. If I take that, I multiply the orthographic matrix. It gets 0. So what if... Wait, let me look at this matrix again. Okay, I'm gonna multiply this times the points transpose. So I'm going to left multiply it, which is what you normally do. And here, it gets negative 1.1 there. Which means... which means I'm bad at linear algebra. Because right... Wait, what the fuck? Right multiplying isn't the same as left multiplying by the transpose. I should have already known that. But I guess now I know it more. So if that's true... Is my orthographic projection code correct then? I guess normally this never happens. This is like the only place... This never happens in like the code base. It only happens in that one scene. But I should double check my projection matrices now. And here, this line should be it should be this @ sign the points dot transpose. And then I guess Manim needs them as row vectors, so I have to transpose that. So does this still run? I guess it did. Switch this back to an interactive embed. Okay, now it disappears at the end. Yeah, there's something about model matrices or projection matrices that I'm missing, definitely. And at least now it's consistent between Python and JavaScript, but it's also disappearing when I apply it. No, I wasn't trying to replace that page. Where is it? Where is it? Where is it? Okay, here's an orthographic projection matrix. Looks like this. And I'm pretty sure we use the symmetric one here. So... I go to where that's defined here. do these match up? Um, 1 over r, and I'm using 2 over width. I think those are the same. R is right. It's the distance you want it to go right. And here we have the width. So the right is width divided by 2. So these are the same. However, I should, just to make this easier, yeah, to make this easier, I should say right equals width divided by 2. Top equals height divided by 2. And then far and near the same. Then I can do, should be able to do this verbatim. Divide by top. 2 divided by far minus near, that's what I have. Negative far plus near divided by far minus near, and then a 1 here. Okay. And then to test something that uses orthographic camera like this. Okay, that still works in the same way. And I crashed my display manager. So that's cool. Are we back? So I just tested that one. Then I should test this one. Okay, and that works too. So I wasn't right before. When I said that a projection matrix can be used without a model in view matrix, that's not true. I think the projection matrix depends on the view matrix. Darn. Well, I guess it's good I learned it now and not like while I was trying to teach it. I think to make this projection visualization work, I think all I have to do is like not flip it in the Z direction. I think that's all. -2 divided by far minus near. This is like, what is far minus near? Far minus near is it's the depth of the cube. Far minus near, and then far plus near. So this is translating in Manim coordinates by -2? No, by negative far plus near. It would help so much if I understood this matrix instead of just copying it. 2 divided by r minus l, 2 divided by t minus b. This actually makes sense. It's scaling the x coordinate so that the distance r minus l is scaled to a distance of 2. Then the distance top minus bottom is scaled to a distance of 2. So that's scaling the x and the y dimensions. In the z direction, it's flipping that. So it's flipping things across. Oh, this is because the camera looks in the negative Z direction. Then this, what is this doing? R minus L, R plus L divided by R minus L? Yeah, I'm not quite sure what that's doing. Although whatever it's doing, it must only rely on projections that aren't symmetric, because when it's symmetric, that goes to 0. Except for the Z one. But I have to figure out what these terms do, basically. And maybe one day I'll figure it out. But not today. I'm just glad that I figured out what was going on with the model matrix, I guess. Yeah. So now when I run this... Oh. Wait. What went wrong here? Git module file name not... Oh. This needs OpenGL tutorial. So when it's at 1... Why is this scale wrong? When it's at 1, it fits. And when it's at 0... Oh, it's not supposed to go from 0 to 1. Oh, this is what I wanted. I want the projection one. Okay, from 0. It still disappears at 1, though. Oh, yeah, that's because... Yeah. So I still actually want to do this left multiplication. That's what I want to do. Now the question is, why is this left multiplication just happen to be better? It just happens to do what I want. No, I'm not going to do that. I'm not going to rely on this left multiplication if I don't understand it. Instead, I would rather just write my own that I understand what it's doing. Okay, so this is the right top far and near. That I can do with here, height here. Get right and top from there. Near 1 far equals 11, I think I'm doing. And then I just won't flip this in the Z direction. So I'll do this. This will be 1, 0. Now when I multiply this, transform mesh, this will be projection matrix. Oh, no comma. And now, close. But I still messed it up. So I guess the Z direction still needs to be scaled. So I'll just do this, I think. No, that still flips it. X, Y, Z. The Z coordinate can be left unchanged, I think. Okay, now I'm guessing. This is me not knowing projection matrices. Okay, so now it's close. I think it's only the translation. So maybe if this was 0... Still no, this is the thing from before. Yeah, this is confusing me. I wish I knew projection matrices better. It's so unclear. Like, this is translating in the Z, in the negative Z direction. Why would you even want to do that? In an orthographic projection. Right. This term makes sense to me. If this was a 0. But then when you apply the matrix, it shrinks too small. I wonder if part of it is potentially being translated outside of the box. Not all of it's being translated out of the box. Okay. I'm gonna have to go back to the left multiplying thing. This. This does it so perfectly. And it turns out I never knew why. Okay, but it has to be the difference. The difference between from a vector transpose multiplied by a matrix on the right and a matrix multiplied by a vector's transpose. A matrix multiplied by a vector not transpose. And what is that difference? I call this X and I call this Y. And then I transpose Y. That's this dot transpose times M dot transpose. P transpose times M transpose. So I guess I could compare these two. It's the difference between multiplying the transpose of Y is V transpose times the matrix transpose to the matrix itself. I try transposing X. It'd be... Wait, I actually don't know if I transposed Y correctly. when you transpose the product, you flip them and you transpose the both of them. Yes, I did transpose y correctly. So x transpose would be m transpose times v. And do any of these compare to each other? X, y, x transpose, y transpose. Not really. They don't have much to do with each other. I guess x is what worked for me. Yeah, I don't know. I'll probably just have to look more and probably just do the multiplication by hand and see why that happens to work. Yeah. Okay, but JavaScript was right. In the meantime, that means I should be able to project these by not passing this uniform and instead transforming these positions. Let's see. This ought to be up here. Now I have the transformed vectors. Now these I have to unpack into the positions array. I think dot elements will do that. Nope. Guess I gotta do dot x, dot y, dot z. Oh, to array. A new array will be created. Oh, and you can give it an offset too. So I guess what I want to do here is let positions. Can I do this? Then say transform 1.to array. Positions offset is 0. This one offset is 3. This one offset is 6. Maybe that'll do it. And then pass the positions as before. Pass to that vertex shader. I look at this. And it still doesn't appear. Great. Yeah. Rent the positions after this. Oh, I'm still multiplying by this matrix that doesn't exist. Well, that didn't fix it. Weird, it's not even printing here. Oh, I have to save. Okay, there we go. I have to do the left multiplication. Okay, then I don't know how to left multiply in this. And this is basically forcing me to understand what happened with that other thing in Python. Maybe I can just search this. Does it mean to multiply a matrix on the left? I want to know what it means to multiply it on the right. Asking why AB equals A transpose B transpose not implied this. Why is false? I don't know if multiplying on the right is ever a valid thing to do. Multiply a column vector by a matrix B on the right. We can't multiply a column vector by a matrix B on the right. That operator is not defined in linear algebra. And Julia gives an error. To get a row vector, we must transpose it. Okay. Multiply this by B, which should give the first row of C. If you multiply a row vector by a matrix on the left, that doesn't make sense. But what does it mean to multiply a row vector on the right? Jeez, there's only these very... This might talk about right multiplication. A combination of columns. Why does it say right multiplication, then the example is left multiplication? Oh, here... Each resulting column is a linear combination of x's columns. Okay. So here... I'm multiplying the x coordinate by this. The y coordinate by this. Now I have to write this out, I guess. Go to a notes thing like this. I'll try doing this for just one of these. So for example, this matrix and I want to figure out what's x dot m. And it's gonna be a matrix, right? This 1 by 4, this is 4 by 4, so it's gonna be a 1 by 4? A 1 by 4. Yeah, that makes sense. So the x coordinate is this. the y coordinate is this. The z coordinate is 0, which is, that does happen to be what I want. And the w coordinate is 1. So that's how that works out. So in this case, the z coordinate is 0 just because the original z coordinate was 0. Whereas in the other example, the z coordinate was negative 1.1 because 1.1 was added to it here. Okay. Well, that just happens to be the way it works, I guess. But now the question is, how can I do this in JavaScript? I guess what I would do is just... Wait. So I'm doing a vector times this matrix. So I transpose both of them, then I would get... So this is something that's equivalent. M transpose multiplied by X transpose. Transpose. This is equivalent. So I could do this. And this would be the proper quote-unquote way to do that. X transpose is just X. So I'd be multiplying on the left by the transpose. Can I transpose in 3JS? I can. Projection matrix, so... Okay, so I'm gonna put the projection matrix there. I'm gonna transpose it. Then then I'm gonna apply the transpose like that. And then I guess I don't have to transpose them back. It worked. I am so good at math. Thanks. That was way more math than I thought it would be. But the biggest takeaway from that is that you cannot just apply a projection matrix without a model and without a view matrix. Although the view matrix is usually pretty simple. The view matrix, it's normally just one entry. Okay, well, I'm gonna save this. House screen triangle. Model matrix triangle. No, it's already saved. Okay, so now what I want to do... I could just set up like a dat GUI or something like that so that I can modify the parameters. Because I want to do this the model with a view and projection matrix. And hopefully that would be less insane. Wait. I'm actually glad it didn't work in Python. Because if there's some inconsistency between those, that could be hard to reconcile. Model visualization. This is using orthographic projection matrix. This is multiplying by the projection, then model matrix. Oh, but it changed the near and far plane. So if I make this the identity, and then I look at the model visualization, did all I have to do is change the near and far plane? Okay, well, got that working. I've been going kind of long, but I kind of just want to keep going. Model matrix. I want to try to do this in JavaScript. And that, I guess, will require .gui. But first, it'd be really nice to just get these matrices straight from Manim. That'd be really nice. And it is doable. Model view and projection. Just using projection and model. Okay, so let me try to do model visualization, I guess. Visualization here. Like this. Okay, so this would look the exact same code. And now I'm going to have to get basically this projection matrix and then a very simple model matrix. So I'm going to print out this projection matrix. Firstly, I'm just going to do this without any transformations. And it's still transformed for some reason. Oh, this isn't even exported. That was weird. And here it's still transformed for some reason. Oh, I have to save that. There we go. Position's not defined yet, so that makes sense. And now I want positions to be basically this. Oh wait, not there. Oh my gosh. This. There. Okay, so there's that. So no transformations yet. Great. Here, this is just a super basic projection matrix. And this one, I think, was applied correctly. This is multiplied in the shaders, so I should be able to pass this to the shader and have it project the vertices without being really annoying. So let Node modules 3. 3 source. Where's JSM? It must be reading from build. Node modules 3 build. Oh, 3.module. Can I just do that? I don't think that'll work. Yeah. I would include there's one question about orbit controls. Import, I'll just say orbit controls. Require. It's not globally scoped, which is what the 3 orbit controls module relies on. It'd be really dumb to get a new package just for that. It's now packaged with 3.js, there's no need to use require. Three examples JSM. Okay. Great, so now the GUI's there. So to use that, all I have to do is, I don't know. So I instantiate new GUI params. What is params? Clip intersection and constant show helpers. Okay, so you set the material from params. Then you add params to the GUI. On change function value. Okay, and that's all you do, I guess. Do you add this to the scene or something? Guess not. Okay, so here's what I gotta do. There's a mesh. Scene camera render. Here I'm gonna do the GUI. New GUI. GUI.add. And I'll just do translation for now. Clip intersection. Okay, so that's the name. Wait. Maybe I should just look at how you use this. Like, what is this string? And there's plain constant. I guess that's the name of the attribute that it updates. Cliffhanger at j.constant equals value. Okay, that must be what it is. which means I want let params. And here I have translation. And this should be a vector 3. Oh, but then that means this has to have three components. So I guess I want an X translation? Hold on. I should just read something on this. Geodot add folder. Then I can add rotation. I guess these are sliders by default. Wait, what in the world? Cube.rotation. I guess you can just pass variables to this. Interesting. That means I should be able to do like the material.uniforms. Oh, but that'd be pretty complicated. I'll just have this be X translation. I can start at 0. X translation out of here. And this can go from -8 to +8. That's step 0.1 or whatever. On change. I'll just print it. Do something like that. And then render again. Fine. So I'll just do that. Now if I refresh this, will I see the... Why do I see it twice? Okay, now I only see it once. Is it just automatically like here? Okay, that's fine. So now, for each of these, I'm going to create a translation, rotation, and scale matrix. So say let transformation equals, it's going to be rotation, translation, and then scale. This probably has utilities to just give me a rotation and scale matrix or something like that. Make translation. Yeah. Make shear, make scale. Yeah, it does. I'm gonna say let translation, rotation, scale. Yeah, I just have to do this for all of these. Oops. Matrix 4. Then here I'm going to do translation dot make translation. And given X, Y, and Z, this will be Rams.x translation 0, 0. This will just be translation. Then I got to do material.uniforms. Then I got to do like dot set value or something. Material uniforms time value. Is there an easier way to set it? Because for a matrix 4, that's going to be annoying. Let's say do translation. Actually, translation equals new uniform like this. And then I'll change this so this have like a model shader. And the only difference is that this will have rotation, translation, and scale matrices. Rotation, I think I want it to be rotated, then scaled, then translated. Yeah. Or do I scale? Translation, rotation, maybe... I guess this is just as good. Translation, rotation, scale. So it'll scale it, then rotate it, then translate it. So that's good. Here's translation, rotation, and then scale. Oh, and there's the projection. Translation, rotation, scale. Oh my gosh. Okay. So this, will this work? I guess, wait, why is this here 3 times? No, there's something off with it. Unexpected identifier. Model vert, model frag. This actually needs to be exported like this. That needs to be used there. Put this in that order. Then I'll need the projection matrix. So I think that'll go there. What's the unexpected identifier? Now I need a comma. Great, that works. So this distance should be -4 to 4? Wait, this is way too much. Oh, the projection matrix is in the wrong order. So this effectively, so that's effectively the model. Does this make sense? So that's 0, that makes sense. Is up and down 4 and -1 and left and right negative? It must be 7.1 and positive 7.1. It has to be, since that's what's happening here. Great. Okay, then I could do the rest of these if I want. Let me just... Y translation, Z translation. This would be -5 to 5. This would be -10 to 10, I guess. Oh, and I didn't even need an on change. Wait, did I? Oh, it's only console.logging. Okay. I can do Y translation and Z translation. With this, I can do grams.x translation. Y translation. I can do that. Refresh this. And I have the X translation, Y translation, Z translation. Although it can't be far not to... I think if I made this like 11... No, I can't go to 11. Okay. Great, so that works too. Model visualization. If I can get that working, then the next thing to do would probably be to try to render a Bezier whatever, a vectorized object. Cool. I guess I might as well do rotation at this point. Just to finish it off. Go from negative... I think it's math.pi. Positive math.pi. And this. Okay. Do that, and that, and that. And transformation matrix equals... Wait, what? Oh, then I did the translation only. There's the translation. Here's where I do the rotation. And it's not appearing. Make rotation is not a function. Really? Make rotation Z. X, Y, and Z. Man. It can't just multiply those together for me. I guess it doesn't know which order I want to do it in. Can I do like some quaternion thing? I guess not. Okay. So to do let I have to do like this, rotation X, rotation Y, rotation Z. I don't even know how to multiply these. Dot multiply. Alright, see you, Blake. Thanks for sticking around. You should not make rotation. I have to set this to. I have to do rotation. Dot make rotation X or whatever it's called. This is this. I have to do this for Y, this for Z. Like so. Then what I'm gonna have to set to this is rotation X. How do you say let rotation? This, then I'll have to dot multiply over and over again. Dot multiply rotation X. I'll do it for Y. I'll do it for Z. And maybe now I can just put rotation here. Yep, that's rotation around the x-axis. Rotation around the y-axis. Rotation around the z-axis. Now I could do scaling. Okay, this is only one function. And I like to torture myself, so I'm gonna do that. Scale, this can just go from like -3 to 3. No, scale can just be one thing. I just have one scale. -3 to 3 like this. And to set the scale, I'll do make scale and just do all of them. I already have a something here, so I can just do scale, make scale. Params.scale, params.scale, params.scale. Then set that there. come back here, and maybe... Right, now I can scale. I can rotate. And I can translate. Great. Although, is this X rotation and then Z rotation? Oh, the Z axis is changing. I guess the Z axis applied after the X axis. Whatever. Okay. That's working as well as I could have hoped to make it work. And it's effectively using a model and projection matrix. I have to work a view matrix in there eventually. I should probably do one with the model, view, and projection, just to get all three of them working. But okay, I've been doing this far too long at this point. This person's using Scheme. Yeah, cool. Well, all I see is an ad. Oh, this guy's been over 3 hours though. It's gotta be really tired. Great, the VTuber just started. So we can raid this VTuber. That was a long one. Alright, I'll see you guys. Thanks for sticking around, everyone.
I don't have a shout out command. Wait, do I? Hi, welcome! How's everyone from the raid? There is no. That's so dumb. I'm sorry, I don't have a shout out command. Also, what the hell is. Hi, everyone! Because I was reading, yeah, just spam the link about you do that, Hello, welcome, Euler. I meant Euler. Yeah, there we go. Check out their Twitch. Let's go. So we're learning how to read. Can't do that today. I don't know. Oh, sorry. Sorry. It's Euler. Euler? That's like. Okay. What are you guys doing today? Thank you so much for the raid. I moved my mouth online. Alright, okay. Do you want me to call you? Well, you said Bo, so